we are ready to begin science. And as I mentioned, we've got a couple of things. We got a lot to do today because we're going to be catching up from what missing a whole 2 weeks of school. So that being said, oh hi, I'm here. Here's where I am. Okay, first things first, I'm going to project something because our science book doesn't have this in it, but I want us all to see this. So give me a second. I want to make it bigger. So for you guys, Seesaw friends, virtual friends, if you go to the one that's Geosphere Part 1, we're going to be looking at the image that is Geosphere Part 1. So if you guys can go to that, and then I am going to pull this up, and I'll try and make it as large as possible for those of us in the room if it comes up. Okay. All right, and I will project this so that we can all see it. All right, I think I've got it all set up now, friends. Present my screen.
Miss Fab, I'm sorry. I was getting my stuff. What are we doing? So on the Geosphere thing, is it on Seesaw?
Zeke, nothing. You've missed nothing yet. You just need to, I'm going to present. So if you've got it on the meeting, you can see it. Or it is the one that says Geosphere Part 1 on Seesaw. Okay. So here's what we're going to be talking about first. All right. The Geosphere, it says the big picture. And the reason I have this projected is because our science book does not talk about the Geosphere in this level of detail that we wanted to learn about, because I'm going to be drawing a picture today. Oh no. Come along. Come along. Shh, shh, shh. Guys, shh, shh. Hang on. Untangling you guys, bringing you because I'm drawing a chart today. I'm recreating this picture that is already on here. So, yeah. Okay. Anyway, we're going to be learning about the layers of the earth. Raise your hand if this is going to be brand new information for you, or if you've seen this somewhere before.
We did it in second grade. We like put it in half, third.
I was thinking you didn't do it in third grade with me.
We did it in second grade.
I'm thinking in second grade because my Landon was at home talking about it the other day, and he's second grade right now. Did you guys talk about this at all last year when you did the rock cycle?
Yeah.
No. I know about it.
We talked with the lava and stuff that like the magma that's in it.
Okay, so you talked about the lava and the magma a little bit, maybe when you're talking about rock cycle, you would talk about that. All right. Okay, so there are several layers to the geosphere, but guess what? Not all of Earth's layers are actually considered part of the geosphere. What? That doesn't seem like it makes sense to me. So we're going to read and find out. Okay, so there's 4 main layers: the crust, the mantle, the outer core, and the inner core. Okay, so the crust is the top layer of the geosphere. That's where we are at right now. When we're out on the playground or you're in your yard, you are on the crust. Okay, that is a solid, right? We're not swimming on it. The dirt is a solid. We're walking on dirt or rock, and it is a solid, right? Okay. It ranges in depth from 0 on the ocean floor to 70 kilometers at the top of some mountains. So 70 kilometers, kilometers are bigger than a mile. So that's even more than 70 miles. Okay. So that would be like driving from straight up for over an hour.
Not that bad.
Right. Okay. It covers Earth's entire surface, and temperatures can range from 0 to nearly 800 Celsius closer to the mantle. So if you're looking at this picture, as the crust gets deeper and it transitions from where the crust is to the mantle, which is the white part, the closer it is to the white part, the ground is getting hotter. Right. Because the deeper you go, the hotter it's going to get. Okay.
Shouldn't the ground melt then?
Do what?
Shouldn't the ground melt?
Is it what?
Shouldn't it melt?
Could it melt? It's not hot enough to melt what the crust is made of. Okay, that's a good question, but no, it is not hot enough to melt what the core is made of. So I'm going to try and draw sort of. Sort of, I'm going to try and draw. These aren't going to be perfect circles. It's going to be okay. And I know I'm not centered on my paper. Don't worry about that either. I was planning to run off the edge of it. It's okay.
That's good. That's fine. It looks really good.
All right. Inner core, outer core, lower mantle.
Upper mantle
Upper mantle.
and crust.
And then the crust, and the crust is not as thick. All right, we're going to call this fancy poster that's really boring so far, Earth's cores, Earth's layers.
Wait.
I'm not calling it layers of the geosphere. I am not calling this layers of the geosphere because not all of these layers are considered part of the geosphere. But we will learn about that eventually. So, guys, stop talking when I'm talking. It's rude. All right, so this layer on the outside, this is where we are. This is the crust. It is a solid layer. Okay? Solid.
Wait, what about the water?
Okay. Some of it is water. Although, well, here's the deal. Some of it, the crust is still there, but it might not be as deep because there's water there, right? So some of the crust goes up and is a mountain. Some of the crust goes down lower because it's the ocean. Did you guys see what I was doing? Some of the crust may be taller because there might be a mountain there. Okay. There might be a mountain range. So if there's a mountain range, that's where it was talking about the crust might actually be. Can you please stop talking when I am teaching? Thank you. So did you guys understand that? So like if there's a mountain range, the crust is going to be deeper there, right? But on the same token, there might be spots where there is water. And if this is all the ocean, the crust might be thinner there because this is the ocean or a Great Lake or something. Does that make sense?
It looks more like an ocean.
So now here the crust is only that thick, right? Virtual friends, can you see what I'm doing? Because I have something else pinned so I can't see.
Yeah.
Okay.
We can't
Okay.
see your emotions.
Okay. We can't see you right now, so that's kind of the problem. Okay, so that's the crust. It's a solid layer. Some places it's thicker, some places it's thinner. It just kind of depends on if it's an ocean, if it's mountains, or if it's just regular ground, like where we're at. Okay. Riley.
Quick question. Are you recording?
Am I recording? I hope so. I think so.
Yeah, you are. You are.
Okay.
Hey, you guys know that. You guys don't think
All
you can
right.
see it.
As we go down deeper, next we get to the mantle. And the mantle actually is divided into an upper mantle and a lower mantle. The mantle is below the crust, divided into upper and lower. It consists of rock that is solid, but can flow. We'll talk about that a little more. And it's about 2,900 kilometers thick.
Whoa.
That's a lot.
That's thick.
Away from boundaries with other layers, the mantle has a temperature of 1,350 Celsius to 2,500 Celsius. So it gets pretty warm there. So
Can it burn a human?
yes, you would not survive. I don't know who raised their hand, but I heard it beep that somebody raised their hand. Go for it.
All right. So I want to know: is there any way can we look up like how thick the upper mantle is? Because from the picture, the lower mantle is taking up a lot of that 2,900 percent of like the kilometers, and I want to know like the temperature, like how it differs and stuff.
Yes. I think our other article that we're going to go to is going to give us more information, but if not, we will look it up. But I think that part 2 that we get to, Josie's going to have more information. Okay. Upper mantle is right below the crust. It's further up from the center. Lower mantle is down deeper. And yes, we're going to look up some more information about this. I know the other article has a little bit of information, more information about the mantle. Okay. The outer core is below that, and it's about from 2,900 kilometers to 5,200 kilometers deep. And it is a liquid. This is the other thing I wanted. This is the other thing I was wanting to remember.
Wait, if it's a liquid, shouldn't it be soaked up into the soil?
Hang on. No, because the soil's way up here, baby.
Oh.
And we're down here now. Okay. So I'm on outer core, and it is a liquid made up of mostly iron and nickel with a temperature of 4 to 5,500 Celsius. This is extra crazy hot. This is our outer core. And it is a liquid. This is important to know that it is a liquid. Okay. All right, hands raised. Go for it.
Josie raised her hand too, so
Zeke, you can
I
go
guess
first.
okay. But so at the bottom of your presenting screen, like there's this thing in the way, and it's I don't know what it says, but it says you're presenting, and there's an option to hide it. Can you do that?
Whoa, right. Where it says stop. If I hit stop sharing, then it'll
No,
stop sharing.
beside it says hide. Yeah.
Yeah. Okay, that's better because I couldn't see some of the article with it in the way.
All right.
Miss Bab, shouldn't the inner core burn the outer core?
It doesn't. No, it doesn't burn it up. We're going to talk about it now. Okay. All right. It's not burning the other layers because when we get to the other article, we're going to learn more about the lower mantle and the upper mantle because it said it is rock that is solid but can flow. So that seems confusing. That doesn't make sense. The other article has more information. So I'm not writing if these are liquid or solid yet because I want to read the other article and discuss this part first. Okay, because there's something happening here that's a little bit special.
It's like magma, basically. That's what it's the oil and everything, I think.
Okay, all right. Lily, you have your hand raised. Josie has her hand raised.
Thanks. So is like the outer core, the only thing that I can really put my mind to is like whenever they're making metal or something, like it's like a silvery, it's probably not silver, but like just this liquid, like do you think it's that kind of liquid or do you think it's like sandy or like has a little bit of rocks in it, or what kind of liquid do you think it is? I mean, I know that sounds weird, like there's only liquid as liquid, but like, do you know what kind it would be or something?
Yes, it said it is, what did it say, nickel and iron. So yeah, it's exactly what you're picturing. Like if you've seen in like shows or whatever on TV where they're like trying to make a sword or something and they're pouring and it looks like, yeah, you're right, like this like a thick silvery liquid kind of. That's what this is.
Iron, molten nickel.
Yeah, it's like molten. It's metal, but it's melted metal that flows like
How do they get
liquid.
down there if it's just on old metal to get it?
Miss Bab.
Kane says maybe it's like a marshmallow because it's a solid, but it can also be moved.
And then it's sticky.
It's not like a marshmallow. I don't know about that one, Circle K.
Miss Bab.
But no, when you've seen on the movies where they're like pouring a sword and making a sword and you see like the grayish, silvery kind of liquid metal stuff. Okay, that's what's there. Now, inner core. Jason.
Or like when people are making fidget spinners. They're like
I've never seen them make a fidget spinner, but anytime you're making something out of metal, you got to melt the metal down and then let it come back up to room temperature.
There's this channel called Colin's Key, and they they mix liquid metal into molds. Oh, what is that?
Yeah, anything that's made out of metal was at one point liquid metal, and then they formed it into the shape that it is. Like the legs of our chairs, that was a liquid metal, and then they poured it into a mold that's shaped that way. That's not metal. That's
Miss
wood.
Bab.
Yes.
This is
So me and my dad, so we're gonna start making knives soon. So we're gonna get a forge, and so we learn a lot about it like every day. We have like this book, and so it's like the metal, it gets orange when you heat it up, and usually when you're making like swords and stuff, you don't get it hot enough where it's a liquid, but that's how it is with most things, and it's really cool. It's interesting.
Yes. Okay,
Don't
DJ.
let yourself-
You
The
have not raised your
reason
hand yet.
that you have to melt it down is because unlike if you took something like slime, like paper, anything like that, or a good example is Play-Doh. You can't just like put something on it and mold it into like a certain shape, like a boy or something like that. It has to be a liquid or like a liquidish that flows because you can't just compress it down and put like a mold on it.
Right. Like I can't just take metal and like squeeze it into the shape that I want, like I could Play-Doh or a marshmallow or something else like that, because different metals at room temperature where we're at are like a solid, like a firm solid. So you have to get them incredibly, incredibly hot, thousands of degrees. And when they get that hot, they actually liquefy and turn into liquid. Okay. Now we're at the inner core. The inner core is the center of the earth. It is a solid ball of mostly iron and nickel.
Wow.
So you'd think it was so hot that it was a liquid, but it's actually a solid.
Is that how?
It is 5,100 to 6,400 kilometers below the surface and reaches temperatures of something cut off. 5,500 and
Blank.
6,200 Celsius.
Thank
Okay,
God.
so it gets incredibly hot, but it is actually
It's
a
so hot, it's going to solid.
solid. And so all of the heat is radiating outward. So this is the hottest part. And so it's so hot here that it causes all of this metal to be liquefied.
Wow.
What do you predict the lower mantle is going to be? This is so stinking hot here at the core that this is all liquefied. What do you think the lower mantle is going to be, DJ?
Okay, so how the upper mantle and the lower mantle kind of like block some of the heat. I think the lower mantle. That's why the crust that's why the crust isn't like deadly heat, like hot. Like that's why you can live up on the top and be on the ground and not be like burning up. And that's also why it's colder the higher up you get into the atmosphere. That's one of the reasons. And the other reason is because you're going up closer to space.
Right. The further we get and the higher we go into the atmosphere, we're getting further away from our own natural heat source at the core. And we're also, once we're in the atmosphere, the oxygen is thinner, right? So there's nothing to trap the heat from the sun. So as we get further and further from the core, obviously the temperature is going down, because it obviously is like the ground, unless it's the middle of summer and you're walking on pavement barefoot, like you're fine to be outside barefoot 99% of the time, unless it's 100 degrees outside and a sunny day on the pavement. That would hurt. But for the most part, we could walk on the playground right now and we're not burning up. It's not melting the rubber on our shoes. It's a little bit chilly. It's winter. It was just snow on the ground, right? So, so let's flip over to our other article now.
Big mountain in real life.
Miss Beth,
Sophie.
what if it's summer? Will the things get hotter or no?
The temperature, that's a good question. Sophie asked, if it's summer, does this get hotter? No, this stays the same. This is not affected by the sun.
It's because as in the summer there's less clouds. That's why, but it only goes to the crust because there's less. Is that not? I thought it was like less clouds.
The clouds don't have anything to do with the season.
More like, there's more UV.
No, remember, where'd my globe go?
I don't know. Like that. Excuse me, man.
Remember that summer is because we are tilted. Hello. Sunshine.
Yay!
Towards the sun.
Summer is because we are tilted towards the sun.
Can I be the sunshine?
Winter is when we're tilted away from the sun. Remember though, then the southern hemisphere gets summer because now they're the ones tilted towards.
Yeah, they're looking.
Okay, so But the inside temperature of the Earth is not affected by the temperature out here from the sun's energy, okay? That was a good question though, Sophie. Okay, let's flip over to the other article. For you guys, I've got to pass that out. Josie, I see your hand raised.
Hey.
Okay, so I have two questions. One, where is like lava at? And two, how do scientists know exactly like the range of how deep it is and the temperature? Because there's a certain point where they just like have to stop digging, and it's like it's definitely impossible to get to the Earth's core.
I'm making a box.
Okay, you guys again. Sorry, my cord came unplugged. Are you guys good? Okay. Josie, all good questions. Let me see if our article says anything, but I think they can drill down and send probes. We can't go that deep, obviously, as humans, but some of their special scientific thermometer-y things probably can go and withstand a lot more heat than we can.
How do they measure?
A lot of times, scientists have to theorize, which means they're taking really educated guesses based on the measurements that they can take. So maybe we can dig this deep. Maybe we can send a probe this deep before it's destroyed by the heat. So based on what we know, and based on what we know about other things that are affected by the core, like gravity and magnetism and other things like that, because all of that you will eventually learn is also based on the core, okay? Based on the things that they can know, they have different math and science formulas that they can figure out that help them fill in the missing pieces. But that's part of why that article said the core is 5,200 to 6,500 or whatever. It gives a range because they don't know an exact temperature of the core, I don't think, because you're right. They can't, I don't think we can actually get to the core. We don't have anything that can withstand that level of heat, I wouldn't think. I could be wrong because I'm not a geologist. But I would highly recommend that you could look up. I mean, you could definitely look this up. I mean, geology is the study of all of this stuff so that we're in right now. So there are geologists that study this all day.
Josie said lava in the mantle.
We're going to talk about where's the lava at. Okay. All right, hand raised was Zico.
I didn't know I had my hand raised, sorry.
Okay, all right, we're going to dig in because I don't have a lot of time to get us through the rest of this. Yes, ma'am. Yes.
Do we do the worksheet that like about the one that we just learned about?
You will, but not right now. Right now, I want to get through the article, and then I'll give you time to work on the worksheets because there's 2 worksheets for today. Okay, so now we've got this article. It's very similar to the ones that we've been doing on all the other 4 spheres of the Earth. Okay, this is our final one, Geospheres. Sean, quit doodling and pay attention. Follow along. I love you. Okay, the geosphere is the solid portion of the Earth. Lily just did one of these. See, she totally just did. The geosphere is the solid portion of the Earth. So we still don't know exactly which of these layers is solid. We got some questions here about the mantle. We're gonna figure that out though, okay? The geosphere is commonly known today as the lithosphere, but the 2 names are interchangeable. So if you hear somebody say the lithosphere, it's hard to say. It's also meaning the same thing as geosphere, which we know is the portion of the Earth that is solid that we live on, okay? The geosphere refers to what we think of as land. Mountains, valleys, plateaus, all of those landforms. All of the landforms. Land. Water would be the hydrosphere, yo. All right. However, the Earth under your school, your home, all around your community, part of the geosphere, even the Earth at the bottom, bring you back over here, at the bottom of the ocean floor. All of that is geosphere. Earth is composed of layers, kind of like the atmosphere was. The hard layer of solid earth beneath us is the crust. Below the crust is the mantle, and at the center is the core. The geosphere specifically refers to the solid portion of Earth, the crust, and the upper mantle. Let me grab my purple because now I can say that the upper mantle is a solid. And these two together make the geosphere. They don't make best friends, they make up the, oops, this marker's not a good one. These two together are the geosphere, okay? That's an important thing to remember, that the geosphere is the crust and the upper mantle. Just throwing that out there, that's a good thing to remember and just keep in your head. All right, Earth's crust. It's relatively thin. It measures about 25 miles deep and around the globe and is made of rocks and minerals. There are two types of crust, continental crust and oceanic crust. I bet you could take a guess. Continental crust is the solid part of the earth which forms the 7 continents. Continental crust, 7 continents. That makes sense, right? Those words sound very similar. So then the oceanic crust is the solid earth that is at the bottom of the oceans, the ocean floor, okay? Oceanic crust is more dense than continental crust, but they are both part of Earth's crust. So more dense means it's like packed tighter together. And that makes sense because they've got the weight of the ocean on top of it, like pressing down on all of that dirt down there and soil. Grayson.
Is there a typo because it says plate tectonics, not tectonic plates?
Nope. Okay, we'll get to it. Although Earth's crust is thin, only 1% of Earth's total mass, it supports all the life in the entire universe. Let that sink in for a moment. It says entire universe because, well, let's be real, we're the only living thing in our universe. So it's all life on Earth. Okay. All right, plate tectonics. Grayson says he's heard the word tectonic plates before, so he thought this was a typo that they flipped this around. Plate tectonics is the study of the tectonic plates, if you flip it around. Okay, so you're not wrong. Tectonic plates are the actual thing. Plate tectonics is the study of those plates. Okay. Okay. So the geosphere is broken. Oh wait, somebody raised their hand. Nope, lies. Okay. The geosphere is broken up into 7 major tectonic plates. They're giant slabs of Earth's crust and upper mantle that fit together like puzzle pieces. But don't confuse them with the 7 continents. It's not one plate below each continent. They're divided up differently than that. It just so happens that there are 7 plates and 7
Well, you
continents.
told me just one plate.
Okay.
Miss Bab, we can't hear you.
You're like frozen. I can't see your picture anymore either.
They probably all were just
Can you
talking
hear
for
us?
1 minute.
Okay, can you hear me now?
Yeah, it's fine.
Okay. All right, here I am. Okay. So don't confuse the continents with the tectonic plates. There's 7 of each, but they're different. Okay. All right. They cover the entire Earth and they contain both the oceanic and the continental crust. Movement and interaction of the Earth's plates is called plate tectonics. Sean, stop. The plates are constantly in motion because they rest upon a semi-solid lower mantle. The lower mantle is composed of molten rock or magma. There it is. You guys have been asking about it. Magma is extremely hot and acts like a liquid. This causes the plates to move slightly. So, like you have learned before, then that's where you see that like rock that's like lava magma, where the rock is actually flowing. That's the lower mantle. That's not the same one.
We're 2 layers.
Semi-solid. So I'm writing semi-solid here. Semi-solid.
Miss Bab, I can't hear you again. What does that mean? Be right back.
Be right back. You're muted.
Okay, I'm on my phone. Is it working okay? I'm giving up on my computer for. So, okay. All right, magma. I wrote on the chart, we've got the lower mantle, which is semi-solid magma. Okay. All right. Tectonic activity happens at the boundaries of Earth's plates where the puzzle pieces fit together. There are different types of plate boundaries, convergent, divergent, and transform. This is really annoying because I can't hold my phone and draw at the same time. Each type of boundary results in different landforms. Okay. At convergent boundaries, just keep it right.
Miss Bab,
Yeah.
don't the tectonic plates, doesn't that have something to do with earthquakes?
Yes, we're getting there.
Yes, it's when they.
Okay. Whoa, baby. All right. So if this is a tectonic plate right here, this is one of my plates. Okay.
Why is it not like shaking too?
Yeah. I'm not Miss Clance. Calm down. Okay. I've got tectonic plates. They look. Okay. We're just gonna. And this is part of the upper mantle and the crust. Okay. Right here. 2 tectonic plates. Convergent boundaries, and they're floating on my liquid magma. There's no water down here in the earth, not this deep. This is where the magma is down here.
Man, I thought
Right?
there's like water beds underneath land.
Honey, we're way deep. We're way deeper. Way deep. Okay. We are on this chart. We are down here. We're right where the upper mantle turns into the lower mantle is where I'm drawing right now. Okay. Okay. So we're right here. We're way far away from where we are. Okay. All right. So that being said, here are my tectonic plates, and here's the magma underneath. So this is solid, right? Because up here, up front is where we are. So this is solid, but it's like floating. It's like if you had a raft, right? It's getting cooler. Okay. All right. Now at convergent boundaries, 2 plates collide, and mountain ranges can form. So that would be convergent that it's talking about. Convergent, the 2 plates, as they're floating along on the magma. And when I say floating, I'm not talking about like you can row your boat to shore or whatever, right? Like they're moving so slightly, because on a daily basis, does it feel like we're moving? Not really. No. It's so slight. No, it has nothing to do with that, baby. But as the tectonic plates over time bump into each other, I don't know, can you guys see my hands? And as they bump into each other, they can collide, and that's how mountain ranges are formed. Does that make sense?
Yeah, we learned about that.
We learned about that like a long time ago. Okay, review. All right, now the Himalaya mountains were formed by plates collided. What?
I can't see you.
We're having technical difficulties. I want you to bear with me. We're doing the best.
Yeah, I can
Okay.
see you, but we can't really see the board. It's very far away.
Okay.
Do you have like a pop socket or something?
Have a what?
Miss Bab, do you have a pop socket? No, she doesn't have a pop socket. You have a little thing on your back.
No, she doesn't. She
She has to stay in the
Okay, now you can see what you're filming. Hold it so that you can pay attention. Okay. All right, you guys good now?
Yeah.
Okay. All right, so convergent boundaries, where the two plates, they're ever so slowly moving towards each other. They hit each other, they collide. Mountain. Okay. All right, now sometimes one plate moves under the other, and that's called subduction. Okay. Subduction. And this happens when an ocean crust goes under a continent crust, forming a deep ocean trench. Okay. So hang on. Subduction looks like this. And so one of them is going to go underneath the other as it moves closer. And what happens then is there ends up being a hole right here. So like it says this happens a lot in the ocean. So if that's the ocean and I'm swimming along, if I were to dive all the way to the bottom of the ocean, there would be a hole right here, like a trench in the ocean. Okay. All right. Then, okay. It says, for example, the Mid-Atlantic Ridge is a long underwater mountain range that formed where two plates moved apart, allowing magma to rise to the surface and form a ridge. So where these come apart, the magma can actually escape a little bit. Okay?
And that's how volcanoes are made.
All right, now. Lastly, transform boundary is where two plates slide past each other. Now, anytime the plates bump into each other, one of you asked about this, anytime the plates bump into each other at all, or even if they move in a weird way, that's where we get earthquakes, right? Okay. So, geospheres, we know it today, has changed drastically over millions of years because of the tectonic plates moving. It's still constantly changing and evolving today. All right. You do not need to know, other than what to answer on your worksheet, about the convergent, divergent, and subduction boundaries, whatever, transform boundaries.
So it's like possible, like over 1 million years from now.
So leave that one blank, like send it in blank.
Yeah, so hang on. Sean just asked, I couldn't hear you, Josie. Hang on. Sean just asked, he says, so like in 1 million years from now, the tectonic plates will be in like completely different places than they were. And yes, because they're always in motion. Right now, way thousands of miles below us, we can't feel it because, like I said, it's moving so slowly, just like we don't feel the earth spinning, right? Because everything is spinning. But the tectonic plates below us are moving so slowly, we don't feel it unless a part of it happens to bump up against something else, and then that causes the earthquakes, right? All right. Josie, what was your question?
So we don't have to fill out anything on the geosphere one that we just did?
No, you do. What I meant to say is you don't have to memorize, like for a test or anything, the whatever it said about convergent, divergent, and transform. You don't have to memorize those 3 types of boundaries. But no, okay. So for today, and you guys will have plenty of time, but in here, they're going to have to work pretty quickly. You have the Geosphere worksheet, and then you also have a label the Earth's layers and color it and write if they're solid or liquid or semi-solid. Okay, so you guys have all of that to do. So I am going to hang up, and I need to make sure that all of you hang up at the end of the call and actually close out your Google Meet tab so that the recording stops, because now that I'm on my phone and I'm not the owner of the call anymore, it won't let me stop recording. So I need everybody to not only stop record, but to actually close out the Google Meet tab.
Miss
Zika.
Fab.
Yeah.
So, on the first worksheet, on part 1, the worksheet says it shows like the crust, mantle, outer core, and inner core, and it shows, well, thickness, state of matter, temperature, and composition. What does the composition mean?
What are you looking at?
The seesaw part 1, like the questions about
it's the first page on it.
I really don't know what you're looking at, because I'm looking at what should be on Seesaw Part 1.
Yeah, I'll present my screen. Yeah.
I can't. It's too small on my phone. So Seesaw Part 1, add a response. Oh, what is that? Hang on.
let me get in yours. You don't have to do page 1. Just do
Okay.
what you already did, Zeke. Yeah, just do what it says on page 2. On page 2, there are directions 1, 2, 3. Do those. Okay.
Yeah, I saw that.
Hold
Okay,
on.
so Miss
So
Bab.
you sent it in as on the first page, it's question 3. And then on the second page is question 1, 2, and 3. So which page do we do?
Don't do the chart. One chart that says thickness, state of matter, temperature, composition. Don't do that.
But do the other 2 pages?
Yes.
Alright.
Yes. And then the other one is just the normal questions that go with the article, like always. Okay. All right, guys. So everybody hang up, and then I'll be able to stop the recording.
Okay, bye.
Bye, guys. Okay, I can't even hang up. I don't know what's wrong with this stupid thing. It's like going crazy. Yes, please. All right, I need 2 people to pass out papers.